do you need? Okanda, you sent me your results.
Yes, doctor.
I mean, I don't know, F1, we use F1 before the function F1, which is the square of the
Yeah.
parameters and you sum them up. So you sent me the other five, if I'm not wrong. Now, what's appearing there? Your algorithm is learning, but it's not learning as quick as possible. I mean, it's learning very slowly. That's the main problem
Mm-hmm.
your algorithm has right now. So my question to you, before just asking to your friends, now when you are creating, as an example, five new elements from the best element, how you are changing them? I mean, how you are, what you are adding to change them, Okanda.
What you're adding means, doctor, those,
So in fact, you select the best solution,
yep.
and what you have done, you have to change or you have to update them. You have to create five new solutions.
Yes.
How you are creating those five new solutions from the best solution? This is my question.
First of all, I generated the new five numbers from -1 to 1, right?
Yes,
Then adding with the previous value and
yes.
like the same function but multiplying it, the same thing.
So you are selecting in the range -1 and 1. Is this correct?
Yes, doctor. But doctor, the email I sent you from function to function, I forgot to change uh, the upper boundary and lower boundary. So I sent you another email changing
Hmm,
changing those values.
I see. So what I want you to do, all right, while we are talking with your other friends right now, all
Okay.
right, how many iterations you are doing for B algorithm? As an example for function one, how many iterations you are doing?
Function one iterations means like
I mean,
we I
after finding the new solutions, you are going back and doing the same thing and again and again. How many times you are performing that thing?
10
This is my
times I
question.
think.
How many times?
10 times.
10 times you are performing? It should be uh, approximately, for your case, it should be 5,000 times. I mean,
Oh,
those steps should be performed 5,000 times. All right.
okay.
And one more thing, run F1 for 5,000 times, but at the end of each 200 iterations, all right,
Mm-hmm.
divide that number that's going to be added to the solution by 0.2. So if your first interval is in the range -1 and 1, all right, when you come to 200 iterations, the range will be in the interval -0.2, 0.2. You are dividing always after 200 iterations, divided by 0.2. So the new values will be found with the new, I mean, solutions will be found by adding this time smaller numbers. Instead of a random number in the interval -1, 1, you will just add a number in the interval -0.2, 0.2. After 400 iterations, divide it one more time by 0.2, this upper and lower bounds. Is this clear what I'm saying, Okanda?
Um, yes, doctor, but mm how can I do it 5,000 times?
So how many times you are performing it right now?
So,
10 times
doctor,
you said?
no, here's the thing. You tell, I just written my program as you said previously. I didn't know that I had to do it 5,000 times. So I think it's just running one time.
One time.
Yeah, generating the values.
No, you are generating the values and you are for the first best one, you are selecting 5, you are generating 5 and selecting the best one. For the second one, you are generating 5 and selecting the best one. When you finish it, the program finishes.
No, then go to the second step. Like next, you told me to do it on the first 10 values. Again, generating the numbers between -1 to 1, and the first 10. I mean, the first 10 index. You told me to do it again for those index, and then the next 10, and then the last 30.
Yes. When you finish all of them, 10, 10, and last 30, what you are doing next?
That's it, doctor.
No, that's what you have done is only one iteration. Now you should go to the beginning and perform this how many times? 5,000 times. You change them, you obtain a new solution set, all right? Your solution is 50 solutions. You will go back to the beginning and select the best 10 again, perform one more time those steps, select the second best 10, perform those iterations. So it should be inside a for loop that will repeat itself 5,000 times. Otherwise, in one iteration, it cannot learn, all right?
Okay.
And another thing, what I'm saying, when you put it into a for loop, that -1, 1 we are using to update the parameters should gradually decrease. So when you put it inside another for loop that will repeat itself 5,000 times, when you come to the 200 iteration, that -1 and 1 should be divided by 0.2. So that interval will be -0.2, 0.2. So you are going to add smaller numbers, etc. All right? So if you do these changes and run your program one more time, I am sure you will get better results. All right? Since the results are you obtain after the first iteration. These are the results that you obtained after the first iteration. But the rest is not there, all right?
Yeah.
Okanda, by the way, when we are going to do the presentation, since, I don't know, perhaps when you write 5,000 iterations, it will work. But in any case, what I am suggesting to your friends, the other friends of you,
Okay.
perhaps those 6 functions that we are going to use, you should present those 6 functions and we should say Okanda has written those functions, all right? Perhaps that's going to be meaningful. And because if it works, of course, your program, it's okay. But if it's not, we should say, first of all, he has written those functions and he has written the program, but there are some small mistakes. That's why the results are not as good as the other 2 algorithms. We can just, I think, do such an explanation.
So, doctor, we will go to
tomorrow when we come together,
yeah.
if you say, I mean, it's working, the results are much more better than the
Previously.
results that you sent to me, then it's okay. No need to say such a thing. But if it's not working, I suggest that those functions, you can just check them. Burkan may send you that paper I sent to him. Do you have that paper as well? I don't know.
Yes, doctor.
All right. In that paper, we use F1, F2, F5. What else we use?
There
F1,
is
F2,
F5,
F5,
F8,
F9, and F11, I think.
Yes.
All right.
Correct.
So you can check how we have written them, and you can say I have written those functions. All right.
Yep.
It's not a big deal.
All right, doctor. Thank you.
But while we are talking right now with your friends, for the first function, try to just write a single for loop that will repeat itself 5,000 initially and see what will be the change in the performance. And additionally, for the same function, after 200 iterations, every 200 iterations, that range, you said the range is -1, 1, that range should be decreased. So the new solutions will be created in the vicinity of the original solution. All right, it's that region will decrease when you decrease those numbers. All right.
Okay. All right. I'll try.
All right. Burkan, sizin durumunuz ne? İyi akşamlar bu arada. Can you hear me?
Yes, doctor. Hello.
Yesterday, if I am not wrong, we just discussed about the PowerPoint presentation, and we said there should be, let's say, for a few pages, it may be 3-4 pages, whatever it is, or 5 pages, that explains each algorithm. So I think you should send them to Burkan until tomorrow. Burkan should combine those information to make a single PowerPoint, slide or presentation should be ready. And tomorrow you should present me the, algorithms before the, real presentation.
Okay, doctor. But doctor, you said just before that if I couldn't generate for 5,000 times, I'm gonna present the functions, right?
No. What I'm saying, your results will change there. All right.
Yep.
Most probably you did it only one iteration. Your results are not good. But when you increase the iteration. Your results will be better in any case.
Okay.
So what I'm saying, when you obtain the results will be put at the end of the what should I say, presentation.
Yeah,
but initially you should send the descriptions, the steps. And I said to you, when I sent you that paper, in that paper there is a part that gives your algorithm step by step. So my suggestion, you can send it to Burkan, and Burkan may combine them all. And till tomorrow, I am sure when you put those iterations and run it right now, you will see that the performance will be better. Even you can mail me. But don't forget, first of all, increase the iteration. Write a for loop that will repeat itself, let's say, 5,000 times.
Yeah. Okay.
The second thing, when you write for loop, inside that for loop, for every iteration, for every 200 iteration, that interval, you set -1 and 1, a random number is selected and added to the solution, that interval will decrease. It will decrease how? Just divide it by 0.2 or divide it by, I don't know, 0.25, something like that. So every time, every 200 iteration, that interval should decrease. You will see that the performance will be better of your algorithm. All right?
Okay, doctor. Doctor, also one more thing. Yesterday you told me that you are gonna tell me how to make my tables for the presentation today.
But for your, what I said in Turkish to your friends, if your results, without making a table, for only running it for one time initially, for 5,000 iterations, if it works and gives good results, what I want from your algorithm only, just run it for every function 10 times, only 10 times, find the average and find the standard deviation for it. All right? And forget about tables right now, because your parameters are very different. How we are going to do it? You should change your whole program. That's the main problem. As an example, you selected 10, 10, 30. Is this correct?
Yep.
If I say you the first parameter is 10, the second parameter is 10, just change them 15, 15, or even 20, 20.
Okay.
Is your algorithm automatically will do that such a change?
No.
No. That's why making such a table will be difficult for B algorithm. And that's why I'm saying, first of all, let's see whether it will yield a result. If it's going to yield a result, we can explain tomorrow. I can explain you how you are going to explain to the jury members why you are not going to create such a table. All right?
Okay, doctor.
Evet. O zaman Burkan ne yapar? Kendi kısmı geldiğinde Okan da anlatıyor. Okan da when you send your I mean the information about your algorithm to Burkan,
Mm-hmm.
tomorrow we will come together. Either Burkan or Alperen, we will just send their ID number and passcode, and we will just use their Zoom, and they will open their presentation there. And when the time comes, you will explain your part using that presentation. Let's do such a thing because Tuesday, most probably, we will do the same thing. We will open it, but we will give you a chance to share your PowerPoint presentation. All
So,
right?
so
This is
tomorrow
what
is
we are
like a
going to
trial,
do.
isn't it, sir?
Yes, tomorrow,
That's
let's,
good. Yeah.
as if I am the jury member, you will present me and I will just ask you questions.
Okay.
All right? Evet, başka sorusu olan var mı? Ceyda, hazır mıyız?
Hocam merhaba.
Ceyda, selamlar.